This lecture is Introduction to Sorting Algorithms. Hello everyone. In this lesson we will be discussing sorting algorithms. Sorting as a concept is deeply embedded in many things that we do. It's quite often that we like to arrange things or data in certain order. Sometimes to improve the readability of that data, at others to be able to search or extract some information quickly out of that data. For example, something simple, like when we are playing cards. Even though the number of cards in our hand is really less, we like to keep our hand of cards sorted by rank or suit. And let's say this is our hand of cards and we want to keep it in increasing order by rank. Then the arrangement will look something like this. There are so many places where we like to keep our data sorted. Be it a language dictionary, we want to keep the words sorted so searching for a word is easy, or something like a medal tally, where we want to see which team is on top and which team is not performing so well. If we want to define sorting formally, then sorting is the arrangement of elements in a list or collection in increasing or decreasing order of some property. The list should be homogeneous in that all of the elements in the list should be of the same type. To study sorting algorithms, most of the time we use a list of integers, and typically we sort the integers in increasing order of value. So if we have a list of integers, like this, 2, 3, 9, 4, and 6, then sorting it in increasing order of value will mean rearranging the elements like this. 2, 3, 4, 6, 9. And as we have said in the definition, we can do it in decreasing order and the value will look something like this. 9, 6, 4, 3, 2. And we can also sort on any property. What if we want to sort this list on the basis of, let's say, increasing number of factors? So the number with the least number of factors is towards the beginning of the list. If you see, 2 has got 2 factors, 1 and 2 itself. 3 also has 2 factors, 1 and 3 itself. 9 has got 3 factors, 1, 3, and 9 itself. 4 again has 3 factors, 1, 2, and 4 itself. 6 has got 4 factors, 1, 2, 3, and 6 itself. When we sort the list, we just rearrange the elements. Now this was a list of integers. We may have a list of any data type. We may want to sort a list of strings or words in lexicographical order, the order in which they occur in the dictionary. Fork, knife, mouse, screen, key. A list of words arranged in lexicographical order would look like this when sorted. Fork, key, knife, mouse, screen. And we may have a list of complex data type as well. Sorted data is not just good for presentation or manual retrieval of information. Even when we are using computational power of machines, sorted data is really helpful. If a list is stored in computer's memory as unsorted, then to search something in the list, we will have to run a linear search. In a linear search, we start at the first element in the list and keep scanning the whole list until we get the element we are looking for. So in worst case, when an element will not be in the list, we will compare it with all the elements in the list. So if there are n elements in the list, then we will make n comparisons in the worst case. And to think about the kind of data that modern computers deal with, what if n is really large? If we take n equal to 2 to the power 64 and imagine that one comparison will take 1 millisecond. Then it will take 2 to the power 64 milliseconds. Try to convert this to seconds, hours, days, and so on. This will amount to some years. But if our list is sorted, then we can use something called binary search. And with binary search, if the list is size n, it will take only log of n to the base 2 comparisons to perform a search. So if n is equal to 2 to the power 64, it will only take 64 milliseconds. Sorting as a problem has well been studied, and a great deal of research has gone into designing algorithms for sorting. Some of the sorting algorithms you will be studying are bubble sort, selection sort, insertion sort, merge sort, quick sort, heap sort, and radix sort. But this is not all. And you can imagine how important sorting problem is, so we have many algorithms for sorting. We often classify sorting algorithms based on some parameters. First parameter we want to classify on is time complexity, which is a measure of time taken by an algorithm with respect to input size. Some algorithms will be relatively faster than others. The second parameter we use for classification is space complexity, or memory usage. Some sorting algorithms are in place. They use constant amounts of extra memory to arrange the elements in the list. While some sorting algorithms, like merge sort, use extra memory to temporarily store data, and use of data grows with input size. The third parameter we talk about is stability, and this one will take some explanation. Suppose we have a set of cards like this. We want to sort these cards in increasing order of rank. We have 1 3 of diamond, we have 1 9 of spades, and we have 2 6s, one of club and the other of heart. One possibility will be this. The cards are sorted by rank. We've got 3, 6, 6, 9. But if you see in the original list, 6 of club was before 6 of heart. When we arrange the assortment sortedly, the 6 of heart has to come before the 6 of club. Stable sorting algorithms, in the case of the validity of key or on the property of which we are sorting, preserves the related order of elements. So if the key is equal, if an element was before in the original list, then it will also be before in the sorted list. A stable sorting algorithm guarantees that. So if we use a stable sorting algorithm, we will get this sorted list where the 6 of club will come before the 6 of heart. The next classification parameter is whether sort is an internal sort or an external sort. When all of the records that need to be sorted are in main memory or RAM, then we refer to this type of sort as internal sort. If the records are in auxiliary storage like disk or tapes, then we call such a sort an external sort. There is one more parameter on which we may classify sorting algorithms. Whether it is an algorithm is recursive or non-recursive. Some algorithms like quicksort and merge sort are recursive, while others like insertion sort and selection sort are non-recursive. This is it for a basic introduction. Until next time, see you.